Welcome to the YouTube channel of Unique World Education. In this video, we are going to discuss about the NEET previous year questions from the chapter Alternative Current of Grade 12 Physics. So I have clearly explained about the as a one-shot video for the chapter Alternative Current in the previous video. So please go through the previous video. Those who are not watched, please go through the video first, then come for this video, because in that video I have clearly went through the topics which is required for the NEET in the for the chapter Alternative Current. So after watching that video, just come for this video, and in this video we'll be discussing the questions from the previous year NEET papers like 20. I have taken the 2024 to 2020 exams papers, and I have found that each year there is a chance that we can expect a 2 to 3 questions from Alternative Current chapter. 24 they have asked 2 questions, 23 they have asked 4 questions, again 22 2 questions, 21 2 questions. It is going like that. So we have to make a conclusion that we can expect one question from the transformer, one question from the other part. Let's directly move on to the question. The first question is like, the ideal transformer turns ratio is NP by NS. NP by NS is given as 1 by 2, and we need to find the ratio VS by VP. And here we know the transformer ratio as, what is the transformer ratio? NP by NS will be equal to VP by VS will be equal to IS by IP. And here what is given? NP by NS is given as 1 by 2, and they are asking for VS by VP, and it is clearly it will be 2 by 1. Why? NP by NS is 1 by 2, so VP by VS also will be 1 by 2. So but we need VS by VP, it will be 2 by 1. The option 2 is the answer. The answer is 2 is to 1. Okay, let's move on to the next question. This is also a question asked in the 2024 NEET exam. A 10 microfarad capacitor 10 into 10 raised to minus 6 farad is equal to 10 raised to minus 5 farad capacitor is connected to a voltage of 210 volt. Its frequency is equal to 50 hertz as shown in the figure. The peak current in the circuit. So peak current in the circuit they are asking, but we have to connect the RMS current as RMS current multiplied with root 2 is the peak current. I hope everyone know this one, because RMS current is equal to peak current divided by root 2. So peak current is equal to RMS current multiplied with root 2. So here first we need to find the IRMS. So what is given actually, the source voltage always we have to consider as a RMS voltage. So source voltage is given as 210 volt, VRM is given, we need to find the IRMS first. So then it is easy to find the I0. IRMS is equal to, we know that the source voltage by the total impedance. Here the capacitor is connected. So what is the impedance of the total circuit? That is the capacitive reactance. So first step you need to find the capacitive reactance. XC is equal to 1 by 2 pi FC. Let's substitute it. 1 by 2 pi into, what is F? Clearly it is given 50, and what is C? 10 raised to minus 5. So you can just cut like 1 by 3.14 into 2 into 50, it is 100. Then 10 raised to minus 3 will come. You take the 10 raised to 3 at the numerator by 3.14, or else you can write 1000 divided by 3.14. Now, so after this we can find the after this we can find the IRMS is equal to 210 VRMS divided by 1000 by 3.14. Solve the questions, you will get the answer. You will get the answer as option B, option 2, 0.93. So 210 divided by 10 raised to 3 divided by 3.14. You can just solve it. You will get the answer 0.93 ampere. Option 2 is the answer. Let's move on to the next question. So let's move on to the next question. This is a question asked in 2023. Here the net impedance of the circuit, here L is given as 50 by pi millihenry. So make sure you are converting it into Henry. And capacitor is given as 10 raised to 3 by pi, so it should convert it into 10 raised to 3 by pi into 10 raised to minus 6 farad. And resistance is given as 10 ohms. And we need to find the total impedance. So what is the equation of total impedance? The root of xr square plus xc minus xl the whole square. It can be xl minus xc the whole square, no issues. And r we know, but we need to find xc and xl. So xc is equal to 1 by 2 pi into f into c. Everyone know that equation. So 1 by 2 pi into what is f given? 50 hertz. See, check the figure. 50 hertz. 50 into c. What is c given? That is 10 raised to 3 by pi. So take the pi into the numerator, pi by, but it is converted, we have to convert it into microfarad. So here we will get pi by 2 pi into 50 into 10 raised to minus 3. I am taking it here, it become pi by into 10 raised to 3 by 2 pi into 50. So pi and pi you can cancel, it become 10 raised to 3 by 10 raised to 2, you will get the answer 10 ohm. So you got the answer as xc as 10 ohm. Understood? xc as 10 ohm. Let's find the xl. What is the equation? 2 pi into f into L. So just substitute 2 pi into what is f here? 50 into what is L given? 50 by pi into 10 raised to minus 3. Substitute it, just cancel the pi. 2 into 5, 100 into 50. So 100 into 50 into 10 raised to minus 3 you will get. And what is that? 5 into 10 raised to 3 into 10 raised to minus 3, you will get the answer 5 ohm. So you got the answer as the resistance is 10 ohm, inductive reactance is 10 ohm, capacitive reactance is 10 ohm, inductive reactance is 5 ohm. Now let's find the Z. It is very simple. So Z is equal to root of R square, 10 square plus Xc minus XL or XL minus Xc. It will be 10 minus 5 the whole square. You will get the answer 100 plus 10 minus 5, 5 square 125. I'm sorry, 25. So you will get 100, 125. The options, we can just select the options like so 125 you can just like 25 into 5 you can write. See, 125 you can write it as 25 into 5. Root 25 is 5. Root 5 is the answer. So what is the answer for this question? 5 root 5, option 3. Okay, let's move on to the next question. So next question, let's move on to the 2023. So these are the two questions asked in 2024. Next question is from 2023. Let's move on. Okay. Here in a series LCR circuit, the L is given as 10 mega millihenry, 10 raised to 10 into 10 raised to minus 3 henry. Capacitance is 1 into 10 raised to minus 6 farad. Resistance is 100 ohm. Okay. What is the frequency at the resonance? Okay, so it is very direct question. F is equal to 1 by 2 pi root L, 10 into 10 raised to minus 3, 10 raised to minus 2 into 10 raised to minus 6. 1 by 2 pi root of 10 raised to minus 8, you will get 1 by 2 pi into 10 raised to minus 4, you will get 10 raised to 4 by 2 pi. Solve the question like 10 raised to 4 by 2 into 22 by 7, you will get 7 into 10 raised to 4 by 44. By solving you will get nearly 1.59 kilohertz, because they are asking for the resonance, the frequency at which the resonance occurs. The answer should be option number 4. So let's move on to the next question from 2023. So the next question is 2023 NEET questions. Let's do that question. So let's do this question. A 12 volt. So you see that inductive reactance, capacitive reactance things are coming, and the transformer questions are also coming. This is the second question from 2023 NEET. A 12 volt 60 watt lamp is connected to a secondary. So output power is directly given 60 watt. A step down transformer, whatever it is, whose primary is connected to, so input voltage is primary is connected to 220 volt means input voltage is 220. Assuming the transformer is to be ideal, what is the condition of ideal transformer? Output power will be equal to input power. So this is called ideal transformer, that is efficiency is 100%. So what is efficiency? Output by input. So efficiency is 100% means we can take efficiency equal to 1. This is how we are getting output equal to input. Output power is Vs, Is is equal to Vp, Ip. And output power is given. What is the current in the primary winding? We need to find the Ip. So Vp is given, we need to find the Ip. But we know this relation Vp Ip is equal to VSIS. And what is VSIS? It is output power. So we can directly substitute Vp Ip is equal to 60 watt. Understood? Because output is connected to the secondary. So here Vp is given 220 into Ip is equal to 60, and Ip is equal to 60 by 220. You will get around the 0.27. The option is 1. You have to practice it. Okay, you have to practice the calculation. Try to solve the question in 1 minute itself. Okay, let's move on to the next question. So this question is connected. Okay, this is very important question. An AC source is connected. It's a question from the 2023 NEET. An AC source is connected to a capacitor C. Okay, an AC source is connected to a capacitor C. Due to decrease in its operation frequency, first of all, let's understand what is the relation between capacitive reactance and frequency. Both are inversely proportional. So, operating frequency decreases, capacitive reactance will increase, so current will decrease. Understood? Frequency decreases, capacitive reactance increases, the opposition increases, so or definitely current will be reduced. So what current? What is the answer here? Capacitive reactance decreases. No, that's not the answer. The displacement current increases. No, that's not the answer. In the case of capacitor, we can just equate the conduction current as a displacement current during its charging. So what can be the option? Displacement current decreases. So let's move on to the next question. Okay, so this is a question from 2022 NEET. So you check the questions from 24. We just started with the transformers. Then one question from the capacitive reactance. Then 23 one question. 23 next question. 23 again one more question. Fourth questions we have discussed from 23 NEET. Now we are going to the 22 NEET. A series LCR circuit with the inductance 10 Henry. So when you read it, write it in the paper itself. 10 into 10 raised to minus 3 Henry, capacitance 10 microfarad, 10 into 10 raised to minus 6 farad, resistance is 50 ohm. Is connected to an AC source of voltage V is equal to 200 sine 100 t. We can just compare as V0 sine omega t. If the resonant frequency of the LCR circuit is V0 and the frequency of the AC source is V, then, so first of all, we need to find the AC circuit. That is, what is the resonant frequency? We know that resonant frequency omega is equal to 1 by root LC. Omega 0 equal to 1 by root LC. What is the resonant frequency? Here we can directly get it from like 1 by root of 10 raised to, what is L? 10 into 10 raised to minus 3, 10 raised to minus 2 into, what is this answer? 10 raised to minus 10 Henry. I'm sorry, a mistake I have made here. This is 10 Henry it is given. It's not millihenry, it is Henry itself given. So it is, okay. We'll get it like this. 1 by root of 10 into 10 raised to minus 5, because capacitance is 10 raised to minus 5. Will get 1 by 10 raised to minus 4. What is the square root of 10 raised to minus 4? 10 raised to minus 2. You will get it as 100. So what is the omega node? The resonant frequency happens at omega node is equal to 100. And we know that 2 pi f naught is equal to omega 0 and 2 pi f naught is equal to 100. And what is f naught is equal to 100 by 2 pi is equal to 50 by pi hertz is the resonant frequency. So omega 0 equal to, that is f0 equal to, or mu 0 is equal to 50 by pi hertz is the first answer. Which one is giving? This is giving. So option either 3 or 2. And here also directly from the question it is given as omega equal to 100. So what is F then? 50 by pi, same as like. So here resonant frequency and the frequency of working it is given as 50 by pi. So what is the answer? Option 2 is the answer. Everyone check what I found. Actually initially I found the omega naught resonant angular frequency and I found the resonant frequency. I got it 50 by pi. Then from the source voltage I took omega as 100 and F as 50 by pi. So omega and resonant frequency both are same. We can equate the answer as option number 2. Let's move on to the next question now. Next question is given as 2022. The peak voltage of the AC source is equal to, we know that the peak voltage of AC source is root 2 times RMS. So, or else we know that RMS voltage is equal to peak voltage divided by root 2. Peak voltage, I'm sorry, VRMS is equal to peak voltage Vm or V0 by root 2. So here the root 2 times the RMS voltage. So what is here? Vm is equal to root 2 times RMS value of AC source. Let's move on to the next question. So next question is from 2021 NEET. So we just discussed 2022 two questions. Now there is a question from 2021 NEET exam. A step down transformer is connected to an AC main supply. So VP AC main supply is connected. So it is input. Actually VP is equal to 220 volt is made to operate at 11 volt to 44 watt. So it is very simple. Output power is already given 44. Output power is 44. Same type of question we just did in the previous year. The ignoring power loss in the transformer means what is the output power will be equal to the input power delivered. So we can write the equation Vp Ip is equal to Vs into Is. And what is the current in the primary? Same type of question we need to find the Ip. And here I can write Vp Ip is equal to 44. Why? Vp Ip is the input power, Vs Is is the output power, and in place of Vs Is I can substitute 44 because 44 watt lamp we are connecting at the output. So output power is 44 and 220 voltage is given as Vp and Ip is equal to 44 and we will get Ip is equal to 44 by 220. You will get the answer like 0.2 ampere. Find the answer. You will get 0.2 ampere, option number 1. Okay, let's move on to the next case. Now we are going to the very good question 2021 NEET. An inductor of inductance. I will just make it bigger. Okay. An inductor of inductance L, a capacitor of our series are connected in series to an AC source of potential difference volt. A LCR circuit is connected to a voltage. Potential difference across L, so I am writing it as VL, is VL is 40 voltage and VC is 10 voltage, VR is 40 voltage. Okay. Now, amplitude of the current flowing through IM, amplitude of the current means maximum current is 10 root 2. What is the impedance of the circuit? We need to find the impedance of the circuit. I am writing the total impedance of the circuit. We can write a relation like VRMS is equal to IRMS into Z, and Z is the total impedance, and Z equation will be VRMS by IRMS. So we need to find VRMS first, then we need to find IRMS. We will get the answer. Understood? So first of all, let's find out what is the total voltage in the circuit. So I'm just okay. What is the total voltage in the circuit? Total voltage will be is equal to VR square plus VC minus VL or VL minus VC the whole square. This is we know like the total voltage will be vector sum of total voltages, each individual voltages. So VR is 40 square plus 40 minus 10 the whole square. So you will get 1600 plus 3 0, that is 900. You will get the answer. 50 voltage is the VRMS you can take, because that is the source voltage. 50 is the VRMS. Now IM is given, we can find the IRMS. It is very simple. IM by root 2. What is that? 10 root 2 is given IM by root 2. You will get root 2 cut. It will get 10 ampere. And what is the Z now? Z is equal to VRMS by IRMS is equal to, what is VRMS? It is 50 by 10 is equal to 5 ohms is the total impedance. Let's see that which option it will come. 5 ohm, option number 4 is the answer. Okay, you just rewind the video once again and you can just practice the question again and again. Alright, so this is how we can do the question. All the concepts are coming in this question. First we found the total voltage just using the vector equation, that is the VRMS, and IM is given, we found the IRMS, and if you know the VRMS and IRMS, it is easy to find the Z, that is 5 ohms. Clear? Let's move on to the next question. Like 2020 questions, we can move on. So this is a question from 2020 NEET exam. A 40 microfarad capacitor. So take that one. 40 microfarad. 40 into 10 raised to minus 6 farad. I'm asking you to do it as a homework. I will give you the way, and you have to find the answer and comment you have to find the answer and write your answer in the comment box. C is equal to 40 into 10 raised to minus 6 is connected to a voltage VRMS. So write it at that time itself, 200 voltage. Frequency is 50 hertz. RMS value of current, it is very simple. IRMS is equal to VRMS by XC. So first step, find XC. You know that 1 by 2 pi FC. Everything is given. You can find XC, and VRMS is given 200 voltage. Substitute it and find the answer, which is the option. Comment your answers in the comment box. Alright, let's move on to the next question. A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, phase difference between the current and voltage is pi by 3. So what is the phase difference of a RLC circuit? Tan phi, right? So tan phi is equal to pi by 3. Clear? So the phase difference between the current and voltage is pi by 3. Instead of C is removed from the circuit, the phase difference is again pi by 3. So what is tan phi again? What is tan phi from the equation? It is XC minus XL by Z. Alright, XC minus XL by Z. So if when we are removing this one, XC minus XL, when we are removing the, first we are removing L, we will get pi by 3 as XC by Z, and when we are removing the capacitor, it becomes tan phi is equal to pi by 3. Again we can write XL by Z, and from this two equation it is very clear XL is equal to XC. What is this condition? This condition happens when resonance happening. So the circuit is at resonance. So what is the power factor of the circuit? Power factor is cos phi is equal to R by Z. Nothing. Power factor of a circuit at a resonance will be equal to 1. So how I found the circuit is at resonance? Because when L is removed, the phase factor is phase difference is pi by 3, that is XC by Z I got. And here otherwise if you get a question like this, when L is removed, when C is removed, there is no change in the phase difference, we can just conclude that the circuit is in the resonance condition. Then at resonance condition, power factor phase difference will be 0 and power factor cos phi is equal to 1. So let's wind up the video right now. We have discussed around 12 questions from the 4 years 20, 21, 22, 23, 24 question papers we have discussed, and in the coming videos we will be discussing like this. One chapter I will do as a one shot video. In the next video we will be doing the NEET PYQ questions. Okay, thank you all. Bye.